Hello everyone, welcome to Dr. Ravi's Academy. In today's class, you will be learning how to develop the lateral surface of a pentagonal pyramid. So usually for a pentagonal, for pyramids as well as for cones, we will be using radial line method of development. And let us look at the problem here. A pentagonal pyramid, side of base 30 mm, height 52 mm, stands with its base on HP and an edge of the base is parallel to VP. So the orientation is given that let us draw a XY reference line and he said that the base edge is parallel to VP means it's parallel to XY. So draw an edge of 30 mm, mark 30 mm on this and extend a little, measure outer angle 72 degrees and draw a line of length 30 mm. And again here also extend this, measure 72 degrees. Here also it is 72 degrees and mark the length, that is 30 mm, which is given, and this as center with the help of compass draw a circular arc and with this cut this so that you got the pentagon with required orientation. And it's a pyramid and you have to locate the midpoint. In order to locate the midpoint, let us erect perpendicular bisectors to two adjacent sides. So this is the midpoint, and let us give the names for the corners of the pentagon. I am calling it as A, B, C, D, and E. The midpoint I am calling it as O. O is apex, and the bottommost point I am calling it as P, that I am keeping in parenthesis. And as you know that for a pyramid you have slant edges. Join all the corners with the center. Join all the corners with the center. So these represents a slant edges. Now the top view of the pentagon is completed. Let us project it. Draw the projector and measure the height. Height is given, it is 52 mm, and let us draw a line of length is equals to 52 mm, and from all the corners draw the projectors and join with the apex. And this you can see it is near to the plane which is hidden, and you can mark dashed line 424242 notation. Here also it is 424242 notation. Of course, this is exactly passes through the axis, you can make it dark. So this is the very first step of the problem. After completing this, now it is clearly described. It is cut by a plane perpendicular to VP, means perpendicular to blackboard, and it's inclined at 40 degrees to HP and passing through a point on the axis 32 mm above the base. So let us measure 32 mm. This is the distance. This distance is 32 mm from the base. This is 32, and locate this point, and with the help of a mini drafter tilt the angle 40 degrees and draw the cutting plane. Now the notation for the cutting plane, as you know that it is long chain line, ends with the thick, and above this cutting plane you can write down CP stands for cutting plane. So this completes your cutting plane, representation of the cutting plane, that is in front view. It appears as a line and the notation is long chain line with ends thick, and above that you write down CP stands for cutting plane. Now let us locate the points of intersection between the slant edges and the cutting plane. I am just moving from left to right. So this is the first point. I am calling it as 1 prime. the point of intersection. Let me represent all the corners also here. This is A prime, and this is B prime, C prime, D prime, and finally this is E prime. So here 1 prime is on O prime, A prime. This is bottom is, you can call it 3 prime. So 1 prime is the point of intersection between the cutting plane and the slant edge O prime, A prime. And the next is OB. So this is what is your OB, and this point is, you can call it as 2 prime. 2 prime is on O prime, B prime. And lastly, it is this is your 3 prime. 3 prime is on O prime, C prime, and back of it, and you can see that this point is that is O prime, D prime. It is cutting at a point 4. Let me rewrite this as 4 prime, and finally the last point is this is 5 prime. I have located all the points of intersection between the slant edges and the cutting plane. And observe carefully, none of the slant edges is parallel to xy. So all these slant edges are not true lengths of the slant edge. So you have to calculate the true length of the slant edge. For that purpose, what you have to do is, any one of the slant edge, you can make it parallel to the xy reference line with O as center, this OA as radius. Draw a circular arc, make it parallel to your xy reference line. I am calling this as A1. This point I am making just parallel to xy line. Project it upwards and join with the apex. This is your A prime. Join with the apex. This line A1 prime is the true length of the, this is the true length of the slant edge. Only this one line gives you the true length. Likewise, you can make this also parallel OC. You can make it parallel. It is a C1 and project it upwards, and you can join with the apex, and this is also gives you the true length. Now what you have to do is, because in development of the surfaces you have to always consider true lengths. For that purpose, let us locate 1 prime on true length line, draw a horizontal line. So this is, you can call it as 1 prime, 1 subscript 1 prime. So this O prime 1 prime gives you the true length of the first point. Similarly, 2, you can draw a horizontal line to intersect this particular point. This you can call it as 2 1 prime. 2 1 prime is on true length line. And 3, because it's nearer to the right edge, you can draw a horizontal line, and this point you can call it as 3 1 prime. And this is also O prime, C prime, C1 prime. This is C1 prime. O prime, C1 prime is also true length, and 3 prime is true length. Now 4 1, this also you can draw a horizontal line which is nearer to the right edge, and this point is 4 1 prime. This point is 4 1 prime. And lastly, you can see that 5 prime, draw a horizontal line to the left, and this point is 5 1 prime. So you have located all the points on the true length of the slant edges. And let us draw a semicircle with the radius is equals to O prime A1 prime, which is the true length of the slant edge. Let us draw a horizontal line. I am drawing a horizontal line, right? Locate somewhere the apex, that is O. I am using capital letter. O prime A1 prime as radius. With the help of compass, locate this point, right? And draw a semicircle. Draw a semicircle, right? Now, with this length, you can, as you know, this base edge is 30 mm with this as center, 30 mm is radius. You can locate 5 edges. This is first edge, second edge, third edge, fourth edge, and maybe fifth edge. So join with this. All these are the true lengths, and it gives you. So this is not required, right? Now you mark that all the edges with the capital letters. It is first one is OA, second one is OB, OC, OD, and OE. After OE, your A will be, because it's after developing your left edge will be repeating on the right edge. So you have developed the pyramid. Now we want to develop the frustum of the pyramid. For that, as you know very well, with the help of compass, O prime and 1 1 prime. O prime 1 1 prime as radius, locate the point. So this is your point 1, and point 2. Point 2 is on this, and you have drawn horizontal line. You have got it is 2 1 prime. O prime 2 1 prime as radius. Let us locate the second point. That is somewhere here. It is your 2. 3. 3 is, as you know, this is 3. O prime 3 1 prime. 3 1 prime. So this is your point 3. And 4 is this point on the hidden edge. It is, this is what is your 4 1 prime. O prime 4 1 prime. This length, little more length. Then you can take it as this is your 4, and 5 is this length. It is 5 1 prime, this length, which is marked here 5 1 prime. You can look at it here. This is your 5, and lastly 1 is will be same, and you can look at that. It is somewhere here. Join with the help of scale all these points with HB pencil. 1 2 2 3 3, you can write down here. 3 4 4 5, and 5, this repeats 1. So at the end of it, you highlight the result with HB pencil. So you can draw the join AB with the straight line. This is what is your base edge. BC, a straight line with HB pencil. CD, a straight line. DE, a straight line, and finally EA. So this is what is your required development of surface of a frustum of a pyramid. Thank you.